Assalamu alaikum, I am Qazi Osama Jamil and topic of our video is CPU performance concepts and various benchmarks. I am going to explain performance concepts here while Akhundzada Shahriyar will be explaining various benchmarks. When trying to choose between different PC, different computer, performance is an important attribute. Understanding how best to measure performance and limitation of performance measurement is important in selecting in computer. When we say one PC has better performance than another, what do we mean? CPU performance can be judged on basis of 2 points. The first one is execution time, that is the response time, and the second one is the throughput. Consider we are running program on two different desktop PC. Which one is most efficient? Which one is fastest? We will say that the fastest one is the one which gets the job done first. If we are running data center that has several servers running the job submitted by many users on a single computer, we would say that the fastest computer is the one that completed the most job in a day. Consider another example in which we have a passenger airplane and the speed is given, the passenger capacity is given, and throughput is given. Now which one is the fastest, Boeing 747 or Concorde? This depends upon how do we define it. Now it can be defined on basis of 2 points as we have discussed it earlier. It can be speed or it can be a throughput. Now in terms of flying time, in terms of speed, we would say that the Concorde is more faster than the Boeing 747. And why is that? We can see that the speed of Concorde is 1350 mph while the speed of Boeing 747 is 610 mph. So it is 2.2 times faster than Boeing 747. Now defining it in terms of throughput, we would say that the Boeing 747 is much faster than the Concorde because the throughput of Boeing 747 is much greater than Concorde. Now I am going to tell you about some simple formula related to performance concepts. First of all, the performance is inversely proportional to the execution time. If we want to increase the performance, we will have to decrease the execution time. They both have inverse relation with each other. If we have a computer X and a computer Y, the performance X divided by performance Y is equal to execution time Y divided by execution time X, and the result of both will be constant because the performance and execution time are inversely proportional to each other. CPU execution time for a program is equal to CPU clock cycle for a program multiplied by clock cycle time. This is a simple formula for measuring the CPU execution time. Another important term to be explained here is cycle per instruction, that is CPI. CPI is the total cycles taken by each instruction. One way to define CPU clock cycles is to define it in terms of instruction. CPU clock cycle is equal to instruction for a program multiplied by average clock cycles per instruction, that is CPI. So finally we have formula CPU time, that is the execution time, is equal to instruction count multiplied by CPI into clock cycle time. So that's it from me. Now Akhundzada Shahriyar will be further explaining various benchmarks.
Assalamu alaikum, my name is Akhundzada Shahriyar and I'm going to be talking to you about benchmarking. So basically the meaning of benchmarking is the process of determining the performance of something, more specifically a technical component of, in this case, a computer such as a CPU, which is a central processing unit, or a GPU, which is a graphical processing unit. So there are many types of benchmarking. There are different ways of benchmarking techniques that we use in the industry, and I'm going to be discussing some of those in this video. So here are some types of benchmarks that we use. First, we have real programs. Second off, we have kernels. toy benchmarks, and then synthetic benchmarks. So moving on to real programs. Now these are actual real programs that are being used in our day-to-day lives, and we judge the performance of our components such as the CPU by recording its performance while we're using a program such as any for example, let's say a compiler or text processing software, a word processing software, anything that we use on a regular uh, day-to-day basis, and which is a real program. So these are going to be benchmarks that we carry out using real day-to-day usage programs. Next up, we have kernels. Now, kernels are basically components of a full-fledged real program that are preferably which are more heavy on using the CPU. So we're going to use these specific components of a real program to test our CPU or our GPU, and this way we get to avoid the unnecessary objects in the real program, and we can only focus on the kernels or the components of a program which matter to us and which matter to us determining the performance of our component, such as the CPU. Now, some examples of these are the Livermore loops, which are a very old technique. They were developed basically on Fortran, but since their success, they have been ported into many other languages, many other modern computer languages, and they are still used in the industry. Moving on, we have toy benchmarks. Now, these can be very small benchmarks that we can create ourselves. These can be between 10 and 100 lines of code, and we can use these by compiling them ourselves on any compiler. So some of the examples of toy benchmarks are the quicksort algorithm, any sort of puzzle, or the sieve of arithosynthesis. So okay, moving on, our last technique of benchmarking are the synthetic benchmarks. Now they take the statistics of all operations from many programs, and then they get the proportion of each operation and the proportions of CPU usage of each operation, and then they write a program based on those proportions. Now, this is basically a more complex benchmark, and this gives a better and more detailed uh, conclusion as to the performance of our component, such as the CPU. Okay, moving on. We'll move on to a very modern day technique of benchmarking, which is widely used in today's gaming community more, I'd say. Now, these are using video games as benchmarking tools. Now, let's see. We can measure both the CPU and the GPU's performance by using video games, basically. So first off, we're going to look at CPU benchmarking by using video games. Here in this example, we have used a very popular video game, which is PlayerUnknown's Battlegrounds, more commonly known as PUBG. Okay, so in this benchmark, we have played the game on 1080p resolution, and then we have measured the CPU utilization on various different types of CPUs that are in the market today. And the results are shown in this graph. We can see that the AMD CPUs have performed better as their CPU utilization is lesser. Now, I must say that these numbers that are given in this graph are actually percentages. Now, the top ranking CPU in these benchmarks is the AMD Ryzen 7 1800X, which only uses 24% of its CPU while playing this game. Okay, moving on. Here we have the GPU or the graphical processing unit benchmarks of the GTX 1080 Ti graphic card. Now the way we measure this is by measuring the average frame rate, which is the FPS, more commonly known as the FPS. Now that is basically frames per second. Now in this graph, we can see the number of frames that the GPU can produce per second. The frames per second it can produce. Now, the more frames per second a GPU can produce, that means the better its performance is. And this way we can benchmark which GPU is the better one in this case. So in this graph we have a lot of GPUs, and in this way we can measure GPU performance as well as CPU performance. And this was basically it about benchmarking, and this is it for our video presentation. Thank you.